Can you tell me from the diagram that is drawn what point D is? It's a midpoint. We know it's a midpoint because they have given us these two congruent segments there. If you take from any vertex of a triangle and you draw the segment that goes from the vertex to the midpoint of the opposite side, it is called a median. How many medians can you draw in a triangle? 3. I can draw 3 medians because what is a median? I start with a vertex and I draw a segment to the midpoint of the opposite side. So I could find another midpoint right down here, and I could draw that median from A, hits the midpoint of the opposite side. And then I could find the median of this segment right over here, and I could draw from B to the midpoint of the opposite side. And guess what? Whether mine looks like it or not, they are concurrent, which means what? What does concurrent mean? They all intersect in one point. So that point has its own special name. It's called the centroid. So here's our third special concurrent point in triangles, a centroid. Now there are some mathematical relationships that we need to know besides how to get it. We get it by drawing the medians of a triangle, and now we know what the medians are. But the centroid measures, those median measures, have a special math relationship. If you go AP, the length from A to P, right there, which is from the vertex to the centroid, to that concurrent point, it is exactly 2/3 of the total median from A to K, from A all the way to K over there. It's 2/3, and that's true for any of those medians. If I measure C to P, it's 2/3 of the way from C to J. BP is 2/3 of the way from B to L. So if this segment is 2/3 of the total distance, what do you think this segment is of the total distance? 1/3. Very good. Hopefully that is obvious. Might come in useful to us in the future. So that is called the centroid. And for fun, you can pull up your GeoGebra and you can create yourself a centroid by simply drawing the, how would I get this line segment from A to F? What do I do to get that? How do I know where this goes? Vertex to the midpoint. So all I know is F needs to be the midpoint of this BC side. And then I just connect the segment there. So D, E, and F are all midpoints. And then we just go from the vertex to the opposite side. Use your calculators for just a moment. I'm going to drag this around. Notice all those numbers all change. AF. Now A to F is the complete median length. A to F is 9.61. I want you to take 2/3 of 9.61. In other words, you multiply it by 2 and divide it by 3. 9.61 times 2/3. What number do you get? 6.41, hopefully, is what you get. You notice right there, A to G, 2/3 of that distance. All of those are going to be that way, no matter where I go. I can make a new one, take 9.08 and take 2/3 of 9.08, and you get 6.05 right there, 2/3 of the distance. So those are the facts about a centroid, which we now all have memorized. So right down here, in triangle ABC above, they say FC equals 15. Now, this is a centroid. They didn't say it anywhere right here, but this is a centroid right here. FC is 15. So this whole length, 15. Find each length, F to Q. How will I get the length F to Q? I think I heard it. What do I do? Tell me how I get it, not the answer. Well, we were all so confident a minute ago. 1/3. It's 1/3 of the distance. It's the short one. 1/3. So if I take 1/3 of 15, now I want the answer. What do we get? I get the answer of 5. If I go Q to C, so they want Q to C, what do I do to get the answer? 2/3 of that 15. 2/3 of 15, 3 goes into that 15 5 times. My answer is how much? 10. And hopefully 10 plus 5 equals what? 15. Oh, a length. Woo, very good. All right. We want to check that to make sure. In triangle JKL above, RP is 3.5. Now notice what they have done. When they have made these marks, what does that tell me right here? I've got a midpoint. They're congruent, which means I have a midpoint. And they've done the same thing so that I know all these are midpoints. And if they are midpoints, I know I had medians. And if I have medians that intersect, I know I have a, what's that called? Centroid. Very good. So they say R to P is 3.5. So R to P, that's this one right here, 3.5. J to P is 9. JP, this one right here, that is 9. Find each measure, P to L, P to L. Any ideas? I could say, all right, we know that this is 1/3 of it, right? So I could multiply it by 3 and get the whole length. Let's do that. 3.5 times 3, what do you get? How much? 10.5. And then what would I do with the 10.5? Take 2/3 of it. I just figured out the whole length. So let's take 2/3 of that. What do you get when you take 2/3 of 10.5? Go ahead and round it to the nearest 10th, I guess. How much? 7? I shouldn't have said round it to the nearest 10th. 7. Can anybody think of another way that I could get that answer? This is correct. We figured it out. Yeah. If this is 1/3, what is left is 2/3. How much is 2/3 compared to 1/3? 2 times as much, twice as much, right? So I could just go 2 times 3.5. There's another way. I get my 7. P to S. Trying to find P to S right over there. Well, how in the world could I get that? Now, I just figured out that was 7. Divided by 2? Oh, I have another one, don't I? Yeah! Right over here, I know this is 9. And that stands for 2/3, so this has to be 1/3 of it. So just take that 9 and divide by 2, and how much do we get? 4.5, 4.5. Now, there is something unique about the centroid. The centroid is the balancing point of a triangle, or it's its center of gravity. So when you have your stage show, and you are not going to spin plates, because everybody does that, you're going to spin triangles, because they're more dangerous. So it will wow your audience. You know where to locate your nice little stick. You're going to put a little dot on that triangle at the centroid. How are you going to find the centroid? The medians. What are medians? Vertex is midpoint to the opposite side. There we go. All right. So down here they're going to ask us a question about a graph. They say graph triangle ABC. A is at 110, so 1, 10. There's point A right up here. B is at 5, 0. B is at 5, 0. There's that point. C is 9, 5, they said somewhere. C is 9, 5 down here. They want us, we need to find the centroid. Oh, there it is. I was looking for that information. What are the coordinates of the point where we can support that triangle? In other words, the centroid. So how do I find the centroid? Well, notice what they have done. They said, hey, from this point, if I draw the median, well, in order to draw the median, I need to find the midpoint. How do you find the midpoint when I know 2 ends? Midpoint formula right here. Remember the midpoint formula? Add the x's, divide by 2, add the x's, divide by 2, add the y's, divide by 2. So 3, 5, 3, 5. So they found the midpoint. And then it so happens on this one that going from 9, 5 to 3, 5 is a nice horizontal line. And I can tell how long that line is without even using the distance formula. How long is that line? 6. If this is 3, 5 and that's 9, 5, that's a difference of 6 in between there. So how far would I have to go back to get to this point? Or we could go forward, but let's go back to get to that point. 4. How do I get the 4? 2/3 of 6. If we take 2/3 of 6, 3 goes into 6 twice, 2 times 2 is 4. So if you come back 4, what are the coordinates of point P if you come back 4 from that point? If C is 9, 5, point P would be what? 5, 5. It would be point 5, comma 5. That would be the location of where I have the centroid or my balancing point. Point 5, comma 5. You may have a problem a little bit like that. Second one. The second concurrent point is formed by drawing altitudes. So we need to make sure we know what an altitude is. An altitude is in a triangle. If we start at a vertex, just like when we were doing the medians, but this time we draw a line segment that is perpendicular to the opposite side. That is an altitude. Now notice on this acute triangle that the altitude is inside the triangle. But over here we have this obtuse triangle. There's my obtuse angle. The altitude from point B is not inside the triangle. It is actually outside the triangle. So that altitude is a line that goes perpendicular to the opposite side, or the line that contains the opposite side. So we kind of have to extend that side to find the perpendicular point, because it wouldn't be perpendicular inside. Those are called altitudes. And, surprise, surprise, when you draw all the altitudes, we'll come down here, when I draw all these altitudes, they are concurrent on a point. They all intersect in one point. And that point has its name, Orthocenter. So 4 new terms in the last 2 sections. Circumcenter, incenter, centroid, orthocenter, wherever 4 is on my fingers. The orthocenter formed by the altitudes. I'm not going to pull up the GeoGebra thing this time. You probably believe that it intersects. The orthocenter doesn't have a unique physical property like that centroid does, where it balances the circle. It's just the point of intersection of these altitudes. Find the coordinates of the orthocenter. So we're going to go through another one of these on a graph. So an orthocenter is the intersection of the what? The intersection or the concurrent point of the, what do we have to draw to get the orthocenter? Altitudes. What's an altitude? Vertex to perpendicular to the opposite side, or a line that contains the opposite side. So over here on our graph, if we are going to get the orthocenter, we're going to have to get 2 altitudes figured out. Now I need to know the coordinates of those points, and some of these lines kind of disappeared. That's 0, 1, 2, 3, 4, 5, 6. 0, 6. That's the coordinate of that point. This is the point 1, 2, 3, 4, 0. And this point right here is -2, 1, 2, 3, 4. So that's -2, 4. So those are the locations of the point. We want to figure out where exactly is that orthocenter. All right, I need to get some perpendicular lines. Tell me what we know about slopes of lines that are perpendicular. They're what?
Opposite.
There's something about opposite. Opposite means one's positive, one's negative. They're opposite, one other word. Maybe this will give you a clue. Let's say the slope of one line is 2/3. What's the slope of a second line that is perpendicular to that? It's the negative reciprocal, or opposite reciprocal. -3/2. Those are going to be perpendicular lines. So what I need to do is figure out where my perpendicular line is to one of these sides. I'm going to start with BA. I'm going to start with this line right over here and figure out where is a line that's perpendicular to that comes from point C. So I'm going to have to get the slope of line BA. So, perpendicular lines, we use slopes. How do I get the slope of BA? Let you think about that. Boy, we're full of remembering today. Rise over run, that's one way of getting slope. Let's use that idea. If I go from B to A, I actually have to go down. So what does that mean about my rise? Negative. Down 1, 2, 3, 4, and then run, how far? 6. If I went down 4 over 6, which reduces to negative 2/3. So I need to have a line coming from C that is perpendicular to this one. So what's going to be the slope of my perpendicular line? Positive 3 over 2. Now before we go farther, rise over run is one way of getting a slope. Do you remember the slope formula? If I start like that, do you remember the slope formula? Y sub 2 minus y sub 1. That's the midpoint. When you add them, that's the midpoint. Y sub 2 minus y sub 1. I'm going to go through this to make sure that you remember this way of getting a slope. If I'm going from B to A, my second y is 0, minus my first y is 4, over second x is 4, minus my first x is a negative 2. Now when we subtract negatives, we know we add. I get negative 4 over 6, which is negative 2/3, just like when we did our rise over run. Make sure you know the slope formula. Okay, so here we go. I have a slope of a line. I've got some sort of line. Don't know exactly where it is. Something like that. That's my guess. It's about like that. I need to get this line here. Well, I know the slope of it. I need the equation of this line so that I can figure out the intersection point. So if I'm going to get the equation of that line, we need to go back to our Algebra 1 again, and we are going to remember point slope form. Y minus y sub 1 equals m times x minus x sub 1. The x sub 1 and y sub 1 are the points on a line. This point C is a point on this red dashed line that has a slope of 3 over 2. I need to get that equation. So I'm just going to fill in the numbers. Y minus 6, because that's what point C is, equals my slope. 3 over 2 is my slope. Times x minus 0. Now x minus 0 is just going to be x, so I'm actually just going to write it that way. Y minus 6 equals 3 over 2x. I need to add my 6. Y equals 3 over 2x plus 6. This is the equation of my perpendicular line. Now the reason I needed that is I need to know where does it intersect this line BA. So I need to do the same idea with my point slope form for line BA so I can get that equation. Then we're going to see what we do with those two equations. So if I use y minus y sub 1, it doesn't matter which point I use. I'm going to choose this point because it has a 0 in it. It'll make it easier. Y minus 0, that's one of the points on this line. I'm now trying to get the equation of that line. Equals the slope. What was the slope of that blue line again? Negative 2/3 times x minus the x value, which is 4. Now I need to simplify this one, solving it for y. Well, it's actually already solved for y. Y minus 0 is just y. But I need to distribute my negative 2/3. Negative 2/3 x plus 8/3. I multiply negative 2/3 times negative 4. Now, these two lines intersect, which means they are equal to each other at that point right here. So I need to know, I needed to know the red one. I didn't need to know that blue one. That was fun to do though. I need another altitude. This is one altitude right here. I need another altitude and the equation of that altitude. So let's get an altitude that goes from point B and it is perpendicular to CA over here. So I'm going to go through the same process of figuring out the equation for this line right over here. And somewhere they intersect. That is my point of intersection, or my orthocenter that I'm trying to find. So I need to again know the slope of CA. So if I get the slope of CA, I'm going to use the formula. Go from C to A. What's the second y value? 0. Minus, what's the first y value? 6. Second x? 4. Minus 0. So I get negative 6 over 4, or negative 3 over 2. So there is my slope of the green line, negative 3 over 2. So the slope of the line that is perpendicular, the altitude, is positive 2/3. And a point that it goes through is that point C again. Because I'm coming from C, is that point B. I'm coming from B, negative 2/4 for this altitude. Negative 2/4. So I'm going to come back up to my point slope form in red, and I'm going to get the equation of this altitude. Y minus my y value 4, using this red point slope form, equals m, 2/3, times x minus my x value. X minus a negative 2 is really plus 2. Now this one, I need to solve for y, so I'm going to distribute. Y minus 4 equals 2/3 x plus 4/3. I need to add 4. Y equals 2/3 x plus, if I add 4, that would be 12/3 that I'm adding. I need a common denominator. How many thirds? 4/3 and 12/3 makes how many thirds? 16/3. Now what I have are two equations that intersect. This black one is the equation of the altitude from point C. The green one is the equation of the altitude from point B. They intersect at some location, which means they equal each other at some location. So what I have to do is set these two equations equal to each other. Where does 3 over 2x plus 6, where does 3 over 2x plus 6 equal 2/3 x plus 16/3? So I need to get my like terms together. I've got 3 over 2x and 2/3 x. I'm going to subtract my 2/3 x so that I can get rid of it right over here. What's the common denominator? We don't need calculators. We need our brains. 2 and 3. What's the common denominator? 6. So I have to multiply this by 3. That becomes 9/6. Change that to a 6. I had to multiply by 2. That becomes 4/6. What's 9/6 minus 4/6? 9 minus 4 is what? 5/6. 5/6x. I am going to subtract my 6. I need to subtract 6 to get rid of this. Equals. Well, if I'm going to get a common denominator of 3, that becomes 18. What's 16 minus 18? Negative 2/3. I need to solve for x. How do I get rid of the fraction 5/6? Multiply by the reciprocal, 6/5. 6/5 multiplied by the reciprocal. That eliminates it over here, and I just have 1x. I can reduce. 3 goes into 6 twice. Negative 4/5. Negative 2 times 2. Negative 4/5. I know the x value of that point. I just figured out the x value is negative 4/5. Now I want to check a minute. Does that make sense? Here's 0, 0. If I go back 4/5, it's about right there. Yeah, that makes sense in my picture. That looks like about where it is. Any ideas on how I can get the y value that goes with it? I now know the x. Substitute back in to either one of these equations. It's on both of them. I'm going to come up to the black equation, and I'm going to substitute negative 4/5 as the x in that equation. Y must equal 3 over 2 times my x, which is negative 4/5, plus 6 more. Well, 2 goes into that 4 twice. 3 times negative 2 is negative 6. Negative 6/5 plus, if I have to get a common denominator of 5, that changes 5 times 6 is 30. 30/5. What's negative 6 plus 30? 24/5. My y value is 24/5. My point of concurrency, or the orthocenter, is at negative 4/5, comma 24/5. Now I want to get an idea if that is right. What is that as a mixed number? How many times does 5 go into 24? 4 times with what left over? 4. 4 and 4/5. Let's look back at our picture. I went back 4/5. If I go up 1, 2, 3, 4, and 4/5. That makes sense. Now there's no way I can draw a graph and get that answer. The only way I can get that answer is algebraically. Now I'm going to step you through it again, what we did, because this is the most complicated thing we have today. I'm going to step you through what we did. The first thing is I picked a line that I'm going to be perpendicular to. So I picked this blue line, BA. I found the slope of that blue line. It was negative 2/3. So I know that my altitude is going to have a slope that is the negative reciprocal of that. The perpendicular altitude then has a positive 3/2 slope. Once I know the slope of this altitude that's going to be perpendicular here, I use the point vertex that I'm coming from, point C, 0, 6. I use the 3/2 and the point 0, 6, and I put it into the point slope form. And that gave us our first equation of an altitude. Then I just repeated the process. I took another side of the triangle. I took CA. I found the slope of that. The slope of CA was negative 3/2. So we know our perpendicular line has a slope of positive 2/3. So the point I come from, the vertex I come from to be perpendicular to that green line is point B. Negative 2,4 is the point that it goes with. And I put it back into this equation, the point slope form. And we got the equation of our second altitude. Now that I had these two equations of the altitudes, what did I do when I had the equations of the two altitudes? What did we do right here? Set them equal to each other. So I substituted, really. I took one of them as a value of y and I put it up here. I set them equal to each other. And that allowed me to solve for the x of that point. And then what did I do with that x? Back into one of these two. It doesn't matter which one you pick. Back into one of those two altitude equations, and that gave us the y, and that gave us the orthocenter location, where that thing is going to be drawn. Here's the review of everything we have learned in the last two sections. These are the 4 concurrent points in a triangle. If we draw the perpendicular bisectors, and they've illustrated one, this is a perpendicular bisector. They've just illustrated one. When I do all of them, they are all concurrent at a point called the circumcenter. The circumcenter is equidistant from each vertex. Equidistant from the vertex. That's what they're illustrating here. So it allows us to draw a what? A circle that circumscribes that triangle, that goes around that triangle. The second one we learned to do was if we do angle bisectors. They've only drawn one right here. But if I do all the angle bisectors, they are concurrent at a point called the incenter. The incenter is equidistant from each side of the triangle, right there. That allows us to draw a what? A circle inside, an inscribed circle, a circle inside. Today, we learned what a median was. A median goes from a vertex to the midpoint of the opposite side. And if we do all three of them, they are concurrent at a point. That point is called the centroid. And we learned that that makes it 2/3 of the distance from each vertex to the midpoint. So when I go from here to here, that's 2/3 of the whole distance across. And that centroid has something special about it. What's special about the centroid? Balancing point. And the last thing we did was we learned an altitude. An altitude goes from a vertex. It is perpendicular to the opposite side. All of those are concurrent at a point called the orthocenter. And the orthocenter is nothing other than the fact that we're concurrent there. There's no unique special thing about that one at this level of math. All right, got a worksheet for you to start on with you and your partner.